Hello, viewers. Welcome to another episode on the dynamics. Here we are picking the third course outline, which is the motion under gravity. So this happened to be the 14th episode under the series we are doing on mechanic dynamics. So let's take the concept of what we expect to do under motions under gravity. So first thing, the motion of a body which is thrown vertically upward or which is falling freely downward. In this movement, either upward or downward, we are under studying of what projectile. We are just going to ignore that there is no other force resisting the object from moving up or falling down. That is ignoring the air resistance. You know that air can also resist a free movement of object. When I throw a stone up and there's how do you call it, gravity or force, when I say gravity, there's a particular force which is air flowing. It can resist the free movement upward or downward of what that particle. So in this, if we ignore that air resistance, then we can say that the particles are going to be moving in a straight line. Hence, the equation of motions will be considered in solving questions of any kind that will be in this direction. All right. So that makes it what? A special case of a uniform acceleration which are in a straight line. So hence the equation of motion will still be applied. Let's see what is the continuation. The only force acting on that body is its weight. So if we are ignoring any other resistance, so we are only saying the force acting on the body is the weight of the body. That's the only force. Okay. Then in both cases, upward or downwards, the body's acceleration is going to be acceleration due to what? Gravity, which is denoted by G. So whether it is upward movement, downward movement, the acceleration of that particle will be taken as acceleration due to gravity. All right, which is normally approximated from 9.8 meter per second square to 10 meter per second square. So if a body is thrown vertically downward or a body is falling freely downward in a straight line, then the acceleration due to gravity is going to be G. That is positive what? G. Whatever value given to you, 10 meter per second square, that is going to be the acceleration. The body is falling in line with the force of gravity. We know force of gravity pull object towards the center of the earth. So force of gravity is coming down. So if the body is falling in parallel, let's say parallel, yeah, in parallel with the object, then we can have same acceleration due to gravity. And if it is thrown what? Vertically downward, upward, the reverse of the force of gravity, then the acceleration we are going to be using become a negative of force of gravity. I guess you're getting the two aspects. Upward movement give you negative gravity. Then downward movement give you same what? Positive what? Gravity. So the distance that the body is going to cover, either by upward movement or downward movement, it can also be taken as the displacement from where it is projected to where it stopped and coming back is going to be called displacement. Or the height through which the body is moved will be denoted by h, not by s, as in the previous equation of motion. So let's take it one by one. We are going to have A equals to G, which is the positive one. Therefore, the equations of motion that we already know is going to be one. Let's say U, okay, I think it's V, right? V equals to U plus A what? T. This is the first equation of motion. So we are going to say, therefore, the equations, this is the final velocity, this is the initial velocity, this is the acceleration we are saying is going to be G. Therefore, this become what? GT. Instead of saying A as acceleration, it become what? G. in terms of taking the acceleration into consideration. Then the second motion equation, which is also what do we have? The second equation is going to be S equals to ut plus half at squared. And remember, we are saying the distance and the displacement are going to be taken as h. So this become h, this remain, then this become what? Gravity. So in quoting the formula, you'll be quoting this. If you are quoting the second equation of motion, the Newton's second equation of motion, you'll be quoting this because you're talking about motion under what? Gravity. All right. Then the final one, which we know to be v squared u squared plus 2a what? S. This is also going to be this maintain. It is the acceleration that change to gravity and this thing to what? H. So this give you the third equations of what? Motion. If I am dealing with movement, projectile, movement of body upward or downward. All right. Now, if we pick this, then what if the body is thrown what? Upward. What happens to these equations? Let's look at what that will also be. So we can say that for vertically upward motion, which is A now become negative for G. The equation of motion becomes, so the first equation of motion, since we have it here, I am only going to change the G from positive to negative, and that gives you V equals to U minus what? GT, because G is not negative. Then the second one is going to be H equals to UT minus half of GT. This becomes negative, affecting this. Then finally, we have V squared equals to U squared minus 2G what? H. So looking at the two equations, it's just the same thing. With just knowing that this is negative acceleration due to gravity because the body is moving against force of gravity, moving upward. If the body is moving along with the force of gravity, the equation remains the same, just like we have with the change of G from A and S to what? H. That's all. All right. Now, with this, we can also be asked to find the time taken to reach the maximum height. If, for example, I am asked to find, can I label this I? I'm looking for time taken to reach what? If I'm looking for the time taken to reach what? Maximum height. So when the body is thrown up, before the body will get to the maximum height for it to begin to fall down, there is a velocity propelling the body up. So we have initial velocity propelling that body up. Then when it gets to the maximum height, it stops before begin to fall. At the stoppage, the velocity becomes what? Zero. So if I am picking the first equation, this is what? Where is it? Upward. Upward movement. So I can easily say that using this particular equation, knowing the time, I am going to say that final, initial, this becomes zero. So here, let me just say V is 0, making 0 equals to, let me state it from the beginning. V equals to U minus what? GT. We are going to bring this in here because this will be 0. So 0 equals to U minus this. What happened? This is coming here. GT equals to what? U. Then if you divide, T become U divided by what? G. I'm just managing the space. I believe you get the concept of what I'm trying to put across. If you are asked to find the maximum, the time the object take to reach the maximum height, at this point, initial velocity, final velocity, and the acceleration will be taken into consideration. So we go in for only the first equation of motion, where the final velocity at that point is going to be 0. So I can go with this formula if I can remember it. If you can't, go with this formula and do substitution. Is that okay? All right. Now, in here also, we can also be asked to find the maximum height, not time, maximum height. So let's see. So this is the second one. So we are looking for maximum height. So if I'm looking for maximum height, what is it going to be? The maximum height is just the height it has reached. So in these two formulas, where can I see height? Height is here, height is here. If the time is given, then we can go for this. But if the time is also not given, but the final velocity already known to be 0 and the initial velocity are given, you can find the time and slot it into this to find the maximum height. So I can say that using, let me go for the first one, v squared u squared, where v is what? 0. I can say that I have 0 equals to u squared 2gh. This is coming here. So I am looking for height. So height will become u squared divided by what? 2g. I'm not doing change of subject. I'm just trying to show that it is not compulsory to also start with this. I'm mentioning this for you to know that the kind of equations that can be used to solve questions where you are asked to find maximum height. We can use it directly, knowing that the final velocity is going to be what? 0. Or we can also use this. So alternatively, we can use this. We can also put t equals to u on g into h equals to ut minus half of what? gt, in the sense that the time of projectile is not known. We are not being told the time taken, but we know the final and initial velocities. We know acceleration. Definitely, if given or not, you know it's going to be 10. If it is upward, negative 10, downward, what? Positive 10. So if the time is not given, we put the time by calculation from the first equation into this, making the maximum height equals to u times the t, that is u squared on g. Then this is going to be u times the t. What happened? I'll be having, okay, let me maintain this, and g, then this is going to be u what? G, right? Yeah, that will be it. So don't forget, I think there's a square here, so that square apply. What is going to happen? I'll be seeing that this is going to be squared. This will be squared. So this will cancel one of that. So the height will now become u squared on g minus, we are going to have, you still have the half, right? Then u squared divided by what? G. I think this is what you are going to have. Good. Yeah. Or we can just say h equals to u squared on g minus u squared on what? 2g. Remember, all this does not matter in terms of knowing this. If you cannot be able to remember this, just hold on to the equation directly the way it is, do your substitution with the values provided, then we are good to go. I guess we are okay. I don't want to scare you with all this. Okay, do I have to remember all this before I can solve such questions? No. When the information are given, go ahead, substitute, and you get to the end. It is just like knowing this to the final end. All right. First, time taken to reach the maximum height. 2, maximum height. 3 could be the time of flight. as the body thrown upward, definitely to come down. So the time it takes to go up and return back, that is the time of flight we are looking for. So let's see how we can find that also. So this is number 3, which is for time of what? Flight. Since I've done so many calculations in terms of change of subject, I'm going straight forward with this. The time of flight is going to be the maximum time taken to reach the top, and it's returning twice of that. So the time of flight, it just means that twice the maximum time, or the time to reach twice the time to reach what? The maximum height. That means that the time I'm looking for, already it was this over this. So it will become t equals to, let's say this is the t from the beginning, time of what? Flight. Let me use flight here. That is twice of that. So I think twice, the 2 will be here, right? Twice of what? This. This is what we are going to have. If you cannot remember this formula, what do you need? When you find the time it reached the maximum height to be 10, multiply that by what? By 2, twice of that. Then we are good to go. All right. Remember, the 3 informations I am writing under the body thrown upward. It is just to show the beauty of kind of questions that can be asked. So I am not supposed to just remember these formulas if the weight on me to take in formulas is high. I just need to know the 3 equations, but know which kind to use to arrive at your answer. That is where these things are being derived for you. So let's go for the final one, which is the special case, where we have what? Let me just say special case and see how I can carve the spelling, the sentence for that. Let's say a body which is what? Projected above, what is it going to be? Above what? A ground. Or I say a ground or the ground. So let's say we have, there's a height here. Then we have a ground. Let me just say this is the ground. Then the body is rather projected from here upward. So when the body is projected, remember it will fall back. So if from here to here is labeled as what? X, the distance from the ground to here. Then from here to here is labeled as what? Maximum what? Height. The body is going to come down as it is following. Then I can see that the distance here will be the same as this. Then the distance it moves from this movement is not another distance. No, the body is thrown up. It will come back the same direction. I don't want to draw the line coming back. So when the body will go up, it will definitely come back in the same straight line, not like this. I'm drawing this line to show that when the body gets here, it comes down again. So if I know the maximum height, it means it will move from here to here twice, move up and come down. But it will move the X only once. Do you get it? It's going to move the X only one. Here will be moved only one. So if I am asked to find, let me clean here. So what am I asked to find? If I'm asked to find what? Maximum, let's say this is alpha, right? Maximum height reach from the ground. What is it going to be? The maximum height reached from the ground. The ground is here, and the body is, let's say, on top of a tower before it is thrown. Above the ground, what is the maximum height? The total height is going to be, that will be, let me just say, what's it going to be? equals to the x here plus what? The maximum what? Height we have. If you are looking for the height the body will reach from the ground, even though it was not thrown from the ground, thrown from a certain point above the ground, we are going to add the distance that it is the projectile taking place from the ground plus the distance is reached all together, give you that value. But if we are looking for the total what distance covered, right? Total distance covered. It move up, come back, total distance. Then my alpha, my beta becomes the total distance which is being traveled or covered by the particle is going to be, first of all, let's start from where it was thrown. It is being thrown from here. So to travel the maximum height. Then come back again and travel it before coming to travel the x. So I'll be having this maximum plus h maximum. Let me bring it down. So we are going to have h maximum plus h maximum plus what? X. So this will give you x distance plus 2 of the maximum what? Height. All these things will only make sense for you if you are able to calculate the maximum height reached from which of the scenarios. I think the scenario number 2, find the maximum height using equation 2 or equation 3. If you know that answer times 2 plus the distance of the obstacle, let me pick it that way, wherever the body is being projected from. So let's assume this is a tower. I am on top of a tower and I throw in a ball. So the top of the tower to the ground might be 15 meters. The maximum height reached by the ball is 10 meters. Therefore, 10 meters plus 10 meters plus the 15 meters give you total distance traveled by that particle. I'm sure the concept of what I'm trying to drive into this episode is understood by you. Right away from the motion under gravity, how we are able to identify the gravity as positive and negative, how the equations of motions changes from negative to positive, and under upward movement, how we can find the time it will take to reach the maximum height, then how we can also find the time of flight, then finally the special case when the body is projected above the ground. If all understood by you, I deserve to have a thumbs up for this video. Give it a like, share the video, and subscribe if you have not subscribed, and leave a comment for me to know whether you are following with me.